Hi guys, welcome back. This is the third part of the Waterflow project. A few things have changed, including what the project's going to look for, but overall it's still very similar. We're still going to calculate the flow rates, and we will now look at the concentration of a contaminant within this uh, area. So just to get started, let's press run. Okay, so when the GUI shows up, you can see all these things, and quite a few things have changed compared to the first part. Now there are three access places for the concentrations and the flows. And now your load input file is here, and you can also see the input file that it is. Some values that we'll be working with are the B, K, delta X, delta Y, delta T, N, and D. So just for example, delta X and delta Y are the height and width of the cube or the volume of the actual water that you're looking at. Delta T would be the change in time, and it's the porosity of the material that you're working with. And so now that we can start, first let's look at the input file and see how that works. Okay, so now that we're at the input file, you can see these little tabs right here. There's head bound, which these are the boundaries of the heads. These are the actual heads, and notice that there's two steps just for this case to make the example easier, but there could be multiple steps. It is necessary for the user to skip a line when he wants to change steps because that's part of the coding, and if he were to put values in here, it would mess it up and it won't get the correct steps. Now we need boundaries for the contaminants, and they're very similar to the head boundaries. These are the constant contaminants, and as you can see, there's three right here. That's going to be a value for one of the contaminants, and it's going to change over time. Here, time, we want to say, for example, the first step is going to take 14 units of time, whether it be days, hours, months, weeks. So the second step, it would take from 14 to 28 days, years, depending on the time unit that you are using. So now that we looked at this, we can go to the actual project. Okay, so here's the GUI. We want to load our file, the input. And as you can see, how we showed you in the Excel, it's going to show you the boundaries right here, the head, the value for the heads right here. And for this type of aquifer, we're going to use confined. For B, we're going to use a value of 10. K would be a value of 30. Delta X and delta Y would be value of 10. Delta T, we want to look at every day or month or week, depends on what you're thinking about. The porosity, let's say 0.5% porous. And D is 0.01. So now that we inputted our values, we can actually calculate flow rates and the contaminants and see how it changes over time. So as you can see right here, this is a well on the corner, and as a well, it becomes a negative pressure, and so the water flow tends to go this way. And with the contaminant that we place somewhere here, you can see how the contaminant changes with time. Right here where it says concentration at T equals 14, that's because it shows the last concentration of that step. If we want to move to the next step, it automatically does it again. But this time, instead of a well, we have, it's still a well, but it's not recharging the water. And you can redo it again if you want. So we can actually replay this in a 3-second movie that makes it move really fast. It's a 3-second movie that depicts how the concentrations changed over the time. And now let's say that you're finished with your data, you want to save it. So you click Save Data to Excel file, and it automatically names it Final Data for you, but you can change it. But just in case, for this example, we're going to leave it as Final Data because we have nothing else here. Now it was saved, and we can go ahead and open what we saved. And Final Data, going to the top. It saves our K value, the values of what the 1s and the 2s, 3s, 4, 5, 6 stand for. So 1 is active, 2 is inactive, 3 is a corner. And you can see this has the same shape. The 1s, all these active values, have the same shape as this. So that was the first step. Second, right here we have the flow rates after it finished. Right here we have the velocity x components, velocity y components of the water flow, and these are the concentrations of the contaminants. And that concludes our project. Thank you.